Lesson 96. No new identities, just again a different way of working with them. So this first one says sine of x plus cosine of x, quantity squared, equals 1 plus sine of 2x. All right, so let's go ahead and square this using FOIL. So we'll get sine squared x plus 2 sine x cosine x plus cosine squared of x. Sine squared plus cosine squared is 1. So now we have 1 plus 2 sine x cosine x. Well, I want you to look at your identity for sine of 2x and tell me what it says. It says the identity for sine 2x is 2 sine x cosine x, isn't it? So this is the same as sine of 2x. So we just proved that. But you have to know those identities, guys. You're not going to be able to use them on the test. You're not going to be able to use them on the final. You're not going to be able to use them when you get into calculus, so you need to get used to knowing them. So go back and memorize them if you haven't already. Okay. Next one is 96.2, and it says cosine to the fourth of x minus sine to the fourth of x divided by cosine of 2x. There's those double angle identities again. We're supposed to show that that's equal to 1. All right, so if I had this, let's just say I had x to the fourth minus y to the fourth. How would that factor? It would factor into x squared plus y squared times x squared minus y squared. Okay, so now look at this. How do you suppose that's going to factor? Okay, it's going to factor into cosine squared of x plus sine squared of x times cosine squared of x minus sine squared of x. That's over cosine of 2x. All right, now, what's cosine squared plus sine squared? It's 1, isn't it? Okay, so that's 1 times that isn't going to change anything. Now, get your cards out again and tell me, we have 3 different forms for the identity of cosine of 2x. What's one of them? The first one that we did, what was it? Did you find it? It's cosine squared x minus sine squared x. So those two, numerator and denominator, are the same. What does that reduce to? 1. So it equals 1, which was what we were supposed to show. Okay. Now then, switching gears a little bit, look over on page 554. They draw this triangle 3 times. We'll do it twice. It's the same triangle. It's just using different sides as the base and the height. All right, so we know that the formula for any triangle is 1/2 the base times the height. Okay, so if we use this triangle right here, it would be 1/2 the base, but we need to find the height. So we could find the height by using this angle right here, because we know that the sine of A is x over c, isn't it? Right? So then x would be equal to c times the sine of A, and we can plug that in for the height. So that would be c sine of A. Okay, now looking over here, we can find the height by using this angle. Sine of c would be equal to y over b. So sine of angle c equals opposite over hypotenuse. So y would be equal to b times the sine of c. Okay, now look at it kind of sideways here. So that would make the area equal to 1/2. This time the base would be a, wouldn't it? And the height is what we found for y, which is b sine of c. All right, so you notice that there's an ABC and ABC in all of these. All right? If you use the angle A, then these two sides will be the other sides. If you use angle C, then these will be the other sides. In other words, the next one I can go ahead and write. If I put the sine of B here, this will be 1/2 of what times what? Not B, but AC. Now, do you need to memorize those? No, you certainly don't need to memorize them. All right? Now, if you look on bottom of page 554, all of page 555, and to the top of page 556, what they've done is they've used these three ratios that we just developed, and they go through a really nice concrete development of the law of sines, which we already know and we've already been using. I'm not going to go through that development, but it is pretty interesting in case you were just thinking that someone pulled the law of sines out of clear air. They didn't. This is where it came from. Okay, thank you.